Stan Gibilisco here, proprietor and operator of amateur radio station W1GV. Whiskey 1. Good vibrations at your service to describe a particular characteristic of an antenna that has a resonant length at a certain radio frequency wavelength. I probably should have added that word here. Resonant meaning that it is an integral multiple of a quarter wavelength long, and the antenna radiator itself is this blue line right there. I have shown the distribution of RF current as green, thick stuff here, and RF voltage as a thick black line. Notice that everywhere there is a current maximum, there is a voltage minimum, and everywhere where there is a current minimum, there is a voltage maximum. So, what we call a voltage or current minimum, in this case it is a voltage minimum, in this case a current minimum, we call that a node. So we can talk about voltage nodes or current nodes. Everywhere where there is a current maximum or a voltage maximum like this, we call a loop. So we can have current loops and voltage loops. We can have current nodes and voltage nodes. Wherever there is a current loop, there is a voltage node. And wherever there is a current node, there is a voltage loop. So that's how that works. Whenever there is a voltage loop, there is a current node. And whenever there is a voltage node, there is a current loop. This is getting to be quite a play on words, but what I'm trying to tell you is that all of these points, either nodes or loops, for each individual, let's just change the way this looks a little bit. Let's do a thick purple chisel. Right here is a node for voltage. Right here is a node for current. Another voltage node, another current node. And then here, everywhere that you see a node in either the voltage or the current, or a loop, a maximum in either the voltage or the current, is a very special point on the antenna. And these points are where they are. They're separated by a quarter of a wavelength all along this resonant, straight, long radiator. That's kind of a nice change of pace, isn't it, to have purple? Let's see what else we got. We got extra thick orange. Well, you can use that as a pointer too. Let's try that. I'm just trying to give you a little variety here as I stumble along on a rather intellectually challenging afternoon. But here are those special points. Now, if you attach the feed line to the antenna at any of these points, you will get no reactance. That is to say, you will get a purely resistive impedance. If you feed an antenna at a current node, that would be here, 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 or here, you get a very high pure RF resistance. If you feed the antenna at a voltage node, here, 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 or here, you will get a relatively low purely resistive impedance. The very, very high impedances can be hundreds or even thousands of ohms. The low purely resistive impedances are typically on the order of 50 to 100 or 150 ohms, a good match for coaxial cable of the sort that amateur radio operators like to use. But open wire line, and particularly a well-constructed low-loss open wire line, can be used to feed an antenna at either a voltage node right here, a voltage node right here, or a current node right here, any of these points. And you can also feed it in between these nodes. Now, if you feed an antenna in between any of these nodes, you will get reactance along with the resistance in the impedance at the feed point. But with extremely low loss line at the high frequency part of the amateur radio spectrum, that doesn't matter as long as you've got a transmatch at your station. And for balanced open wire line, I recommend transmatches made by a company called Palstar. And they in particular have a true balanced parallel wire transmatch, and I highly recommend it. So those are the just some of an overview of how antennas behave. If you have a problem with standing wave ratio, you're going to have to try to eliminate the reactance. So you're going to have to feed it at a node or a loop for either voltage or current. But if you don't have a problem with standing wave ratio, for example, a heavy-duty, low-loss open wire transmission line, then it doesn't matter where you feed this thing. And again, it can be any length, a typical length. Here, let's see, how long is this? 1. Looks like about 1.5 wavelengths long at whatever frequency we might happen to be operating at. The frequency that I prefer or operate at the most is probably the 18 megahertz band. But I also operate on 14 and 21 megahertz, and nothing below 14 megahertz because my antenna won't work below that frequency very well for transmitting. Always CW. CW. Morse code. So for now I will say da da di 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 da 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 di 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 da da di da 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 di 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 da di 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 da di da. So long.